Command lists can be built that support the idea of testing. When a command gets run, it might not work. It might work and not do what we expected. It might become unnecessary to run a command based on another command succeeding. It might well be that we need additional commands based on the results of some other command. In other words, we'd like to build some intelligence into our command lists, as opposed to just running one command after another sometimes. So in those cases, we use something called conditional execution, where we execute a command based on a pre-existing condition. There are operators for this. Just like the semicolon allows us to put an operator between two commands, to have two commands run in a row, there are operators that allow us to run the second command based on the success or failure of the first command. Success or failure of a command is designated by the exit status of a command. So the exit status of a command is how one program can tell if another one succeeded or fails. Every command that runs produces an exit status. Every process has one in the operating system. A lot of the time, we don't care what the exit status is. We can tell by the output if a command worked or not. But that's when we are looking at the output and interpreting the results. To do this in a script, you have to have a command that looks at the exit status. So we can use something for that. The exit status itself is simply a number. If the number is 0, the command succeeded. If the number is anything else, the command failed in some way. And depending on the command, that number might give you some hints as to what went wrong, or it might just be a non-zero number to say it failed. When you create a pipeline, there are actually multiple commands. Each command actually has its own exit status. But the only one that comes back to bash is the exit status of the last command that ran in the pipeline. If you run a script, which is a series of saved commands, and all of the commands run, whether or not each command succeeded or failed, the script is considered to have been successful and will have an exit status of 0. You can force a script to exit at any time by using the exit command in your script. If I have a script with 8 lines and the 4th line says exit, only the first 4 lines will run. The default exit status when you do an exit command is 0, successful. If I'm exiting my script early because I've detected an error, I'll use a command like exit space and some non-zero number to indicate my script failed. It's really important, if your script requires a command to work in order for the script to be successful, that if that command doesn't work, you test for it and you exit with an unsuccessful status, so that any other program that uses your script can tell that there was a failure. How do we put this onto our command lines? The simplest way is to use the conditional operator. There are 2 of them. A pair of ampersand characters or a pair of pipe operators. When you put these 2 together, they make a single operator. 2 ampersands is an operator. 2 pipe symbols is an operator. Don't put spaces between them. They must be right against each other. The double ampersand runs the second command if the first command succeeded. The double pipe operator only runs the second command if the first command failed. So if I have a command that fails, like changing directory to a non-existent directory, I will normally get an error message, and I personally can tell it failed because I know what command I did and I can see the error message. A command that needs to be run based on the fact that that failed has no idea what the output was, but it can be run based on the fact that it failed. If I take that command and I put the operator that says, if the first command fails, run another command, and in this case, put a command to exit with a failure status, that means when this command fails, my shell will exit. If I do this at the command line, I'll lose my command line, so I'm not going to run this right now. Another case you might use this for, besides outright command failure, is that some commands perform a task, and even if the command itself successfully tried to perform the task, if the task itself is logically considered to have been a failure, it may set a failure status on the command. Two commands that commonly do this that are useful in scripts are grep and find. Grep looks for patterns in text. It's a searching command. If we tell grep to search for some text, and it can't do the search because it can't read the file, it has an error, unsuccessful status. If it tries to look for the text and the file itself has nothing in it or doesn't contain the text, that also is considered a failure. It's a logical failure as opposed to an error. That also will set an unsuccessful status. For grep to set a successful status, not only does it have to be able to execute the command you gave, but it has to successfully find the text. The same goes for the find command. It will set a failure status if it does not find any files that match the rules that you gave it in the find command. So the first example with the grep command does a grep for the word Dennis in the password file. Normally when we run grep, we're looking for text, and we would like to see the line that contains the text it found. So that comes out. If what we care about is not what was on the line or to see the text, but just whether or not it's there, we would want to run grep with an option that says don't print out the text. I don't want to see it. It's not what I wanted to know. I didn't want to know what was on the line. I just wanted to know if it existed, because I'm going to use a conditional operator to run another command if it does, or perhaps if it doesn't. Output. And now we can put our conditional operator. In this case, we're looking for Dennis in the password file. If it is successful and Dennis is in there, we could print that we found that word in there. If we wanted to know if the user is not there, we could use the opposite text. If we wanted to know if he's not in the file, we would test to see if the search failed, because if the search failed, he's not there. He is there, that one won't fail. If I were to search for somebody who's not in the file, this one would not be found. So the test would fail, and the echo command will run. And we'll find out the user is not there. You can combine these with other operators. You can combine them with pipelines. You can do all sorts of things. In the second example, we use the PS command to print out all processes, and the output should only contain the name of the user that runs the process. So this will print out a list of usernames that are running processes, one per process. If we want to know if a particular user was in that list, we could pipe that to a grep for the particular username we're looking for, such as Dennis. If I don't want that output, I just want to know if Dennis had any, again, I would do grep quietly. I don't want to see the output. I just want to know if it succeeded or failed. And I might say, and if we found Dennis in the output, we can print out that the user Dennis has processes running. We could also do the opposite. Use the double pipe to say they have no processes running if it failed to find the user. A similar example with find is on the slide as well. Try this yourself and see how it works.